Hello everyone, I hope you guys are doing extremely well. Today we are going to discuss another problem in our binary search tree series. The problem name is count BST nodes that lie in a given range. So we are given a binary search tree. That means we are given the root node of a binary search tree and we are given a range. Now what is a range? A range is going to have values from a specified low value from a high value inclusive. Okay. Now, and we want to find the number of nodes that are going to lie in this given range. So let us understand this problem using an example. So let us say we are given the root node of the binary search tree as node 35. Now the left child of node 35 is node 25 and the right child of node 35 is, let's say, node 45. Now for node 25 the left child is, let's say, node 15 and the right child is node 30. Now for node 45 the left child is null and the right child is node 50. Now for node 15 let us say the left child is node 5 and the right child is node 20. Now we want to find all the values that lie in between 25 and 30. Okay, so this is our given range. This is the lowest value and this is the highest value. It will always be in this form, which means low will always be less than or equal to high. So we want to count the number of nodes that are lying in between this range. So for this, what are the nodes? So 35 does not lie in this range. Node 25 lies in the range because it is inclusive. So yeah, this is the first node that lie in this range. So node 25. Now node 45, does node 45 lies in this range? No, node 45 does not lie in this range. Node 15 does not lie in this range. Node 30, yes, node 30 lies in this range. So yes, node 30 lies in this range. Node 50, does node 50 lies in this range? No, node 50 does not lie in this range. Node 5 does not lie in this range. Node 20 does not lie in this range. Okay, so what will be the answer for this? The answer for this will be nothing but 2, because there are 2 nodes that are lying in this range. So we want to return the count, so we are going to return an integer value 2. Okay, I hope the problem statement is clear to you guys. Now we are going to understand how we can solve this problem. So let us understand that. So let us say we are given the root node of the binary search tree as node 33. Now the left child of node 33 is, let's say, node 27 and the right child is node 40. Now for node 27 let us say the left child is node 18 and the right child is node 30. For node 40 the left child is null and the right child is null. Now for node 18 the left child is null and the right child is null. For node 30 the left child is node 28 and the right child is node 31. Now we want to count the number of nodes that are lying in between range, let's say 26 to 41. We want to count these. So how can I do that? Simple, I can just keep a check on every node. So for every node I can just check whether that node is present in this range or not. Okay, so this is the brute force approach of solving this problem. If you are sitting in a coding interview, you should always tell the interviewer the brute force approach firstly. So what is the brute force approach? So we are going to iterate on every node of this binary search tree, and for every node we are just going to check whether this node is present in this range or not. So what we are going to do, we are going to initialize an answer variable in the beginning. So let's say answer variable is nothing but 0. Okay, now after that we are going to iterate on every node of this binary search tree. So we can do any of the traversal. Either we can do the pre-order traversal, the post-order traversal, the in-order traversal, or the level order traversal. I have already explained you all of these traversals in the binary tree videos, so I will request you guys to please have a look at those videos and come back to this video then. Okay, so let us say we are going to do let's say a level order traversal. So let's do a level order traversal. So the first node will be 33. So 33, does 33 lie in this range 26 to 41? Yes, as we can clearly see 33 is present in between 26 to 41. So what we are going to do, we are going to increase our answer by 1, so it will become 1. Now the next value in the level order traversal is node 25. So let me just quickly tell you what is level order traversal. So we traverse the tree by level. So the first level is this level, this is the first level, the second level is this level. Okay, now the third level is this level, and the fourth level is this. So we are going to traverse this tree level order. Okay, so the next node is 27. Does 27 lie in this range? So as we can clearly see, yes, 27 lie in the range 26 to 41. So what we are going to do, we are going to increase our answer by 1, so it will become 2. Now the next node is nothing but node 40. Now we are going to check, does node 40 lie in this range? As we can clearly see, yes, node 40 lie in this range of node 26 to 41. So we are going to increase our answer by 1, so it will become 3. Now the next value is nothing but node 18. So we are going to check, okay, whether node 18 is present in this range or not. As we can clearly see, node 18 is not present in this range, so we are not going to do anything. Now the next node is nothing but node 30. So we are going to check whether node 30 is present in this range or not. As we can clearly see, yes, 30 is present in this range. So what we are going to do, we are going to increase our answer by 1, so it will become 4. Now the next node is nothing but node 28. Now we are going to check whether node 28 is present in this range or not. So node 28 is present in this node, so in this range. So what we are going to do, we are going to increment our answer by 1, so it will become 5. Now the next node is nothing but node 31. What we are going to check, whether node 31 is present in this range or not. So node 31, yes, node 31 is present in this range. So what we are going to do, we are going to increment our answer by 1, so it will become 6. And we are done. We have iterated the entire tree, we have traversed the entire tree, and in the end our answer variable is going to have the final answer. And here we have 6 nodes that are lying in the range of 26 to 41. Now this is the simple brute force approach. Talking about the time complexity of this approach, we are just doing a traversal of the binary search tree. Either we are performing a level order traversal, or we are performing a depth first search like the pre-order, the post order, or the in order. Okay, so talking about the time complexity, it is nothing but big O of n, where n is the number of nodes present in this binary search tree. Talking about the space complexity is also big O of n, because we are going to use extra space during our traversal. So the space complexity is also big O of n, where n is the number of nodes present in this binary search tree. Now if you are sitting in a coding interview, the interviewer may not be pleased with this approach. This approach is good, this is linear, but since this is a binary search tree, we are not using the property of binary search tree. What is the property? The property is all the values that are present in the left subtree of any node, that is all these values, will be less than this value, and all the values present in the right subtree will be greater than this value. So we are not using this property anywhere, and if we can somehow use this property, we can bring down the time complexity. So is there any better approach to solve this problem? Yes, there is a better approach to solve this problem. So how we are going to use that approach now? Let me explain you how. So let us say we are given the root node of the binary search tree as node 55. Now the left child of node 55, let's say, is node 45, and the right child is nothing but node 65. Now for node 45, let us say the left child is nothing but node 35, and the right child is nothing but node 50. Now for node 50, let us say the left child is nothing but node 48, and the right child is nothing but node 52. For node 35, the left and the right child is null. For node 65, the left child is null and the right child is node 70. Now for node 70, the left child is, let's say, node 68, and the right child is nothing but node 72. Now we want to count the number of nodes that are going to lie in between range of 50 to 72. Okay, we want to do that. So how can we do that? We can start from the root node always. So let us start our traversal from the root node. So the root node is having a value 55. Now if root node is having a value 55, that means we can say that, okay, this value is lying in between these intervals. So now we have to go to both the branches. So from 55, so what do I mean by this? 55, from 55, 55 lies in between this range. That means I need to go in both the branches. That means the left subtree and the right subtree as well. Why? Because the left subtree is going to have the smaller values and the right subtree is going to have the smaller values. So from recursion node 55, our recursion can either go to node 45 and it can either go to node 65. So now we reached at node 45. Now okay, for node 45, since node 45 does not lie in this range, as we can clearly see, node 45 is not present in this range. Now what we need to check? We need to check whether node 45 is less than low or not. What is low? Low is this. Now what does this indicate? If my node value is less than low value, that means we need to go in the right subtree, because the left subtree is going to give me a smaller value. If I traverse the left subtree, that is this node 35, it is going to give me a smaller value. So what I need to do, I need to traverse only the right subtree. So now for node 45, we are going to traverse the right subtree only. So we'll reach at node 50. Did you understand why we are doing this? We are doing this only because if we traverse the left subtree, we are going to get again a smaller value, and we just want to traverse the larger value. So now from node 45 we reach to node 50. Fine. Now for node 50, node 50 lies in this range. That means we need to go in the left subtree and in the right subtree both. So for node 50, the left subtree is node 48 and the right subtree is node 52. Now, so we reach here. Now for node 48, does node 48 lie in this range? No, node 48 does not lie in this range, as we can clearly see. So now we don't need to go in the left subtree, we need to go in the right subtree. So the right subtree of node 48 is null. So simply what we can do, we can return 0. And since node 48 is not counted, so we can simply return 0 from here. Now our recursion will reach at node 52. So node 52 lies in this interval. As we can clearly see, node 52 lies in 50,72. So okay, so this will be counted 1. Okay, right? And now, is there any left subtree for node 52? Because now we want to traverse the left and the right both, because this lie in this interval. So now, is there any left subtree? There is no left subtree. Is there any right subtree? There is no right subtree. So the left subtree is returning its 0, the right subtree is returning its 0, and the current value is 1, because this is also counting. So the value that will be returned is nothing but 1 here. So what we have done, for every node there is an answer coming from the left call, and there is an answer coming from the right call, and there is an answer for the node itself. So what will be returning to its previous node? It will be returning its current answer, that is the node will present, and then left answer plus right answer. Okay, now for node 50, the left call is giving me a value 0, the right call is giving me a value 1. Okay, and node 50 is itself lying in this value, so it is also having a value 1. So 1 plus 1 is 2 plus 0 is 2. So it is going to return us 2 here. Okay, fine. Now for this node 45, the left call is giving me a 0 because it is having no left call. The right call is giving me a 2 and it is itself having a value 0 because 45 is not gonna lie in this range. So it is going to return us 2 plus 0, which is nothing but 2. Fine. Now for node 55, we are still left to process the right part. So we reach at node 65 now. Now for node 65, as we can clearly see, node 65 lies in this range. So now we are going to go in the left and the right subtree both. Now as we can clearly see, the left subtree of node 65 is null, right? So now we are going to go to the right subtree. So the right subtree of node 65 is nothing but node 70. So now we reach at node 70. Now for node 70 lie in this range, as we can clearly see. Yes, node 70 lie in this range. So there will be a 1 here as well. There will be a 1 for here as well. What is this 1 indicating? This 1 is indicating that this node is also going to contribute in my result. Okay, right? No, so now the 70 is also lying in this range. So what we are going to do, we are going to make a call for the left and the right both. So what is the left call for node 70? So the left call for node 70, okay, so the left call for node 70 is nothing but node 68, and the right call for node 70 is nothing but node 72. So our recursion will reach at node 68. So node 68, does node 68 lie in this range? Yes, node 68 lie in this range. So 1. Now, is there any left subtree for node 68? There is no left subtree for node 68. Is there any right subtree for node 68? There is no right subtree for node 68. So we are simply going to return from here. So now the left answer was 0, the right answer was 0, and the current answer is 1. So 0 plus 1, 0 plus 0 is 0, plus 1 is 1. So returning 1. So now our recursion will reach at node 72. For node 72, it is lying in this range. So 1 will be marked. Okay. Now, what is the left subtree of node 72? The left subtree of node 72 is null. What is the right subtree of node 72? The right subtree of node 72 is also null. So 0 plus 1, it will be 1. So it is going to return 1 here. Now for node 70, the left answer is giving me a 1, the right answer is giving me a 1, and 1 is its value. So we are going to return 3 here. Now, because 1 plus 1 plus 1 is 3. For node 65, the left answer is giving me a 0 because it is having no left subtree. The right answer is giving me a value 1. Fine. So 3 plus 1 will be 4. So it will be returning 4. Now for node 55, what will be the answer? It will be 2 plus 4, 6, and 1 for here, because node 55 will also lie in this end. So 2 plus 4, 6 plus 1, 7. So the final answer is nothing but 7. That means there are 7 nodes, and let me show you what are those nodes. So those nodes are nothing but 55, then 65, then this 50, and then this 52 and 70, okay, 68 and 72. So these are 1, 2, 3, 4, 5, 6, and 7. So the final answer is nothing but 7. Now talking about the time complexity, the time complexity in the average case where the left subtree will be discarded is nothing but big O of log n, but it will be only in the average case. So the time complexity in the average case will be big O of log n, where n is the number of nodes. And talking about the space complexity will also be big O of log n, because we are going to iterate only the one part of the tree. But in the worst case, the time complexity will again be big O of n. Okay, because in the worst case there will be a degenerate tree and we have to iterate on the every node. But since we are using a property, so in the average case we will be saved. Now talking about the space complexity in the worst case, it will be big O of n as well. I hope this approach made sense to you guys. Now we are going to understand how we can code our logic in the form of code. Okay, so let's understand that. So as you can clearly see, I have already declared a function called count nodes that is taking the root node as an argument. Okay, root node is nothing but an object of class tree node. It is having a constructor that is initializing the value of the node. The left and the right child of any node is by default set as null. Okay, also it is taking two arguments, low and high. Low and high are nothing but the ranges. Okay, so now what is the first thing that we need to do? The first thing that we need to check is if the node that I'm currently on is null. So if root is null, from here I just need to return 0, right? Why I'm returning 0? Because there is nothing that I'm gonna contribute. So if the current node that I'm on is null, I'm just going to return 0. Now after this, what I need to do, I need to check whether I am the node that I'm lying in this range or not. So if my value is greater than or equal to low and root dot value is less than or equal to high, that means this node is currently lying. So what we are going to do, we are going to make a call for the left subtree, we are going to make a call for the right subtree, and we are going to add 1 in it. So what we can write it directly. So return 1 plus count nodes. We are making a call for the left subtree, root dot left, low comma high. So this is the answer. Let me just write it like this. So we are making a call for the left subtree, so left answer. Then after this we need to make a call for the right subtree, so it is nothing but right answer. So right answer is count nodes, and then I need to say root dot right, and then low, and then high. Okay, and now after this I just need to return 1 plus left answer and plus right answer. So this was the first case, that if my current value is lying in this range, in that case I need to go in the left subtree, I need to go in the right subtree, I need to collect both these two answers, and then I'm going to add 1 into it. So okay, now what is the second case? The second case is nothing but if my root dot value is less than low. So if my root dot value is less than low, that means I need to go in the right subtree only. So my right answer is nothing but count nodes, root dot right, and then low, and then high. So in this case I just need to return right answer. Why I'm returning right answer? Because this node is not gonna contribute because it is having a value low. Now what is the next case? The next case will obviously if this value is greater than high. So I'm just writing it for the sake of simplicity. So if root dot value is greater than high, that means we need to go in the left subtree. So let's call for the left subtree. So left answer is count nodes, then root dot left, then low, and then high. Now from this I just need to return left answer, and that's it. That's all about the code that we have needed to do. If the root value is lying in between low and high, we need to go in the left subtree, we need to go in the right subtree, we need to add 1 into the left answer and the right answer and return it. Now if the root value is less than low, that means we need to go in the right subtree only, so we just need to return the right answer. If the root value is greater than high, that means we need to go in the left subtree only and we need to return that answer. So let us take a quick example to run our code. Let us say the root node given to us is nothing but node 15. Okay, the left child of this node is nothing but node 5, and the right child of root node is nothing but node 25. Now the left child of node 5 is nothing but node 2. So root dot left is nothing but node 2. Now the low value given to us is 2 and the high value given to us is, let's say, 15. We want to count the number of nodes that are lying in between names. So print count nodes. Let us pass the root node, the value of low and the value of high. So let's give this program a run and let us check the output of our code. Okay, so the output of the code is coming out to be 3, which is absolutely correct because 5, 2 and 15, these are the 3 nodes which are lying in this range. 25 is not lying in this range. I hope the code made sense to you guys. If you guys still have any queries regarding this problem, please drop your concern in the comment section and I will be more than happy to help you there. Regarding the series, I will be uploading more of the questions in the upcoming weeks, so keep following us. Until then, keep smiling and keep coding. Thank you.